Hi guys, so the first question for today is just do you have a 3018 CNC? And if you do, the next question is just are you happy about it? My guess is just you are not, because I wasn't. When I first got this machine, it was okay to kind of like practicing and learning how to like processing all the cam and using the software and design things for CNC machine. After using the machine for a while, I start to find out that the machine have a lot of things to improve. I almost upgrade everything on this machine, from the anti-backlash nuts, the wasteboard, spindle, stepper motors, rail on the x-axis, stepper motor driver, power supply, like everything. The only thing left are the less screw on the x and y axis, the rail on the y axis, the base frame, these two bar on the x axis, and that's it. Now this machine kind of work at the acceptable level. It is a lot more sturdy, heavier, and it can mill aluminum more consistently, that you don't need to worry that the machine will fall apart when you do it. But I spent almost like $250 to do all these upgrades. So from your original 3018 CNC, you have two choices. The first choice is just to do all the upgrades that I did here and spend about that much amount of money. The second choice just to spend around the same amount of money, maybe just a bit more. You can build another machine that is bigger, more sturdy. All the rails or all the axes will be fully supported. The spindle will be bigger and more powerful. The stepper motor will be like bigger and also stronger. And everything for the control of the machine will be also much better. So let me just show you my design, the way I make all the parts and the way I put everything together. This is my design for the new CNC machine. Is very simple. All the pieces here you can cut out from your 3018 CNC very easily. The three hardest piece to cut will be those two plates and this plate for the back of the Z-axis block, because they are big. I'm just going to show you very quickly how I set up the cam for those pieces, and also some trick I'm going to use on the 3018 CNC to cut them out. The other pieces are very easy to cut, so I don't think I need to show you. Other parts will be harder to make because you cannot use your 3018 CNC. The first part will be trim the rail to length, so you can also buy the rail just with the pre-cut length, like 500mm here on the x-axis and the y-axis, and 200mm on the z-axis. But if you buy them, it might be more expensive. For me, I just buy a set of 1.2 meter length rails, and then I'm going to trim them myself using my chop saw. The second part is going to be trimming the aluminum extrusion bar to length, 500mm on the x and y axis here, and 400mm for these two bar. And the third part will be making all the angle aluminum pieces here for the nut housing and also all the fixture on the Z axis. For this part, I only need to cut them to length and make all the drill guide pieces, and then glue them on the angle aluminum pieces and drill them with my drill press. Those three hardest parts I will show you a bit more in details. So now let's move on to the cam setup. Here in Fusion 360, I'm just going to start with the back of the Z-axis block first, because this piece is actually like larger than the working area of the 3018 CNC. So there's some tricks that you will need to do. So first of all, I'm just going to open the step file. Now I will need to rotate the motor so that the length of this plate will be aligned with the x-axis. Okay, so select the body and then rotate, and then click on axis. So I'm just going to click on this hole here and rotate 90 degrees. Click OK. Okay, now just go to manufacturer, create the stock. For the reference point, I'm just going to choose the middle point here and on the top surface of the stock, and go to stock, put 0 and 0. So now as you can see here, the stock size for the x-axis is okay, it's like less than 300mm, but for the y-axis is 200mm, so it's actually larger than 180mm. As you can see here, the size of this piece is actually like larger than the working area of the 3018 CNC, so some details you won't be able to do. For example, those 4 holes here, and also like the outline of this piece, you won't be able to cut it with 2D contours. To make it easier to generate the tool path, I'm just going to make a copy of this piece and cut out some details. For example, those 4 holes, and also I'm just going to seal up this boundary so it will be a lot easier. So let me just show you how. Okay, so now I'm just going to open the new piece. I'm just going to do the same. I'm just going to rotate it. Go to manufacture and create the setup. The reference point still the same in the middle of the piece. Here I'm just going to put 0 and 0. Now just remember only one thing, just the real size of this plate still 292 by 200 millimeter. So when you cut the stock, just try to cut it to the exact size. For the tool path, you only need one tool path, is the 3D pocket clearing. So I'm just going to choose the 3mm flat end mill. Disable this. All the parameters here are very slow, so you can use it on your original 3018 CNC, I'm sure. And here you don't need to change anything. Here you just reduce this 4, 2, and here just click on selection and click on this surface. And maybe offset is -0.5. And change this a bit more precise. Just make sure that the maximum step down is about 1mm. Shortest path 5 degree, 0.5. Click OK. Well, that's it. So now you just do post-process and save the tool path. So now you are done setting up the cam for this piece. The next step, I'm just going to show you one of the side plate for the x-axis, and then I'm just going to show you how to mill those 2 pieces on the machine. This piece is easy, it's already rotated, so the length of this already aligned to the x-axis. So I'm just going to go to manufacture and create the stock. Reference point, going to choose this corner, like lower left corner, and on the top surface. And here just going to put like 0 and 0. So as you can see here, this piece is actually smaller than the working area, so it's going to be very easy. So I click OK. Okay, so now for the tool path, I'm just going to do 2 tool paths. One is pocket clearing and the other one is just 2D contour. So first of all, 3D pocket clearing. Select the tool. I'm just going to choose the same tool. Disable this. Now, nothing to do. Here, just reduce this for it to go faster. A bit more precise. Nothing to leave. Maximum step down, still 1mm. Shortest path. Maybe go a bit faster here. And click OK. Oopsie. I guess I shouldn't do this because it's going to take a lot of time, so I'm just going to modify it. And here I'm just going to do selection and click on this boundary and click OK. Okay, so everything will be milled through. So that's it. Next step, I'm just going to do 2D contour. Same tool. So contour selection. I'm going to do tab. So I'm going to do like 4, 2.5. Distance probably 50 will be fine. Here, just reduce this as usual. And offset -0.5. And remember to check multi-depth. And also choose maximum roughing step down 1mm. And that's it. Okay, so now the two parts are done. You just need to save it as G-code. So let me just show you how to run them on the machine. For the back of the Z-axis block, I just cut this stock to size 292mm, 200mm on the Y-axis, and I made these two lines here. So the center of the plate will be at the cross here. Next step, I just need to center this cross to the center of the working area. Now you don't need to be exact, but roughly in the center, and make sure that the edge here align with the axis. I'm just going to fix the stock to the working platform using a hot glue gun. Now I just try to lower the bit here to really close to the surface and center the center of the bit to the cross. Roughly like this, and now I can do the tool prop for the Z-axis. Well, that's it. I'm just going to start milling. If all the holes here are not cut deep enough, you can always use your drill bit and drill all the way through to the other side. Now to the side plate of the x-axis, so the size of the piece is almost as big as the working area of the 3018 CNC. So what I did here is just I cut a piece of stock like bigger than the working area, 310mm and 190mm here on this side. So what I'm going to do is just I cover the whole working area of the 3018 CNC like this, and I'm just going to glue it down. Now for the reference of this piece, because the stock thickness is the same, so I don't need to do the Z-axis tool props again. I only need to zero on X and Y axis. Okay, so as you can see, just I move it all the way to the side of the x-axis until it's kind of like hit the limit, so the motor lost a step. So I just move it back just a bit, probably like 1mm or so, and the same on the y-axis. Now I'm going to zero X and Y and start milling. It will take a bit of time to mill all the pieces, but think about the new machine, it will be a lot better compared to this machine, so it will be all worth it. Next step, I'm just going to trim the aluminum extrusion bar to lengths. So I have 5 of these aluminum extrusion bar 3030 series 1 meter length. So I'm just going to tap the holes here at the end of the bar with a M8 tap. I'm just going to use a lot of cutting fluid. And that's it. I'm just going to do this on all the end of the bars. For each of the X and Y axis, you need 4 of the aluminum extrusion bar trimmed to about 500mm. You don't need to be exact 500mm, but they should be exactly the same length. So to do that, I made this piece with my CNC machine. So I can like tighten it here at the end of the bars using the bolt here. So there should be a line here on this end. So I just need to tighten them with some tape here, and then when I trim them, they're not going to move and they should be at the same length. Now both ends are tightened. I'm just going to use some tape to wrap around all the 4 tubes, so just to make sure they don't move when I cut them. So now I'm just going to make a mark of the place where I need to cut it. Just make sure that you have to secure all the tubes to the platform of the saw. Okay, that's it. You are done trimming the bar for the X and Y axis. I only need to like thread the end of the hose here, and then those bars will be ready. I just bought this set of 2 rails, SBR 20, 1.2 meter length. Now I need to trim them to length, and the way I'm going to do it, I'm going to measure from this end to here about 498 millimeter or less, but surely more than 495 millimeter. And the reason is just I need the length of the rails to be shorter compared to the aluminum extrusion bars, so they can be installed on the frame. And also after cutting this end, I'm not going to continue to cut here. I'm just going to measure also from this end to here, 498 millimeter. So that way I'm going to leave the middle here about 200 millimeter, and the holes here will be symmetrical on the both sides. And also these rails are made of steel, so I cannot cut them with this blade. I will have to change the blade to the abrasive blade. And the way I want to trim it, just I cut a bit more into this piece other than like trim into the 200 millimeter piece. So that's why I just leave the piece on the Z axis a bit longer. This is going to take a lot of patience because it's quite slow with this saw. I wish I had 14-inch cut-off saw. It took me like 10 minutes to get one cut, but I only have 4 cuts, so that is doable. And I will need to clean up the end of the bar here so the bearing can slide in. Next step is just to make the nut housing on the X and Y axis, and also the fixture and the nut housing on the Z axis. And these 3 pieces for the X and Y axis, I cut them to 46 millimeter length. These 3 pieces for the Z axis, I cut them to 50 millimeter length. And these 5 pieces, I cut them from the angle aluminum with the side is 1 inch and a quarter width. And this piece is 2 inch width. And here I have all the drill guide cut out. I don't think you can mix them up because of the size. And to mill those pieces, we need one of the small bits like 2 millimeter drill bit or flat end mill, and then you just do the 2 parts just drill. So you drill all the hole at the small size, and then you can do a 2D contour to cut them out, and that's it. So now I'm just going to fix them on those pieces. Just make sure that you have this edge lined up with the edge of the angle aluminum, and then you glue on all the side here. And then you take the other piece that have this notch here to fit into this slot and just press it in. Okay, so it should be clamp all the way in here and push all the way in. So now we can glue it also. Now the pieces are glued here. I'm just going to go to drill press and drill all the holes here because they are fixed. They're not going to move when I drill all the holes, and the holes will be exactly at the place that I need them to be. Before going to the drill press, I'm just going to prepare all the pieces here. First step, I'm just going to do spotting drill. So I'm just going to use the 2.5mm drill bit, and then I just drill just a little bit to make the mark of the hole. Once you are done with the spotting drill, you can peel the pieces off. And they will look like this. You have the position of the holes here. I just continue to do spotting drill on all the pieces. Now for the drilling, I just going to start with all the nut housing pieces first. So those are the pieces just have 5 holes on one side, and the other side either have 2 holes or 4 holes. For the side with 5 holes here, those 4 holes on the side here need to be drilled with the 3mm drill bit, and the center hole will be drilled with the 10mm drill bit. And on this side with 2 holes or 4 holes, they will need to be drilled with the 5.5mm drill bit. For the 2 feature pieces on the Z-axis, you have 2 sides, this side with 3 holes and this side with 2 holes. This side with 2 holes, you will drill them with the 5.5mm drill bit. And this side with 3 holes, these 2 will be drilled with a 5mm drill bit, and this one with 10mm drill bit. And actually thinking about it, I think I should drill these 2 holes with 5.5mm drill bit, so I will have a bit of play. Now all the holes in the center, here, here or here, will be needed to drill with the 10mm drill bit. The last step on those pieces are to thread the holes here with the M6 tab on the side that have 2 or 4 holes. If you don't want to thread those holes, you also can just drill through with the 6mm drill bit. But for me, I prefer to thread them. I forgot to show you one step on this biggest piece of angle aluminum. Just on this side, to install the nuts here, I had to trim off a little bit here. This is just to prevent this piece from touching the back of the Z-axis block when the Z-axis is moving up and down. That's it. Before moving on to the assembly of the machine, I have few pieces to glue together. I have these 4 pieces, these 4 rings, and I took these 4 bearings, 8 by 5 by 16. So I'm just going to slide the bearing in the hole here, and then I will glue this ring on top to fix the bearing in place. You might need to force the bearing in here a little bit, so I might just need to go and pound it in. Yeah, I will need the hammer to pound it in a little bit. What I did to force the bearing in here is just I use this washer to put on top of the bearing, and then I keep hammering it with the hammer so until the bearing slide all the way inside. Now I'm just going to glue this piece on here. To drive this machine, I bought this 4 less screw. These three are 500mm length. This one is 200mm length for the Z-axis, and they are 2m pitch, 2m length, so it will be very easy to drive the machine. And now you can take the 4 pieces of the nut housing here that have 5 holes on one side to install on the nuts like this. You just slide them in and fix them together with some M3 bolt and M3 nuts. You will need 4 of the 12mm length M3 bolts, and if you did the drill correctly, all the holes should line up perfectly. Okay, so the reason for me to make these 4 pieces is to replace 4 of these pieces. If you don't want to make these 4, you can buy 8 of these, but for me to reduce the price, I made those, so I only need to buy like 4 of these. So now for the other 2 angle aluminum pieces on the Z-axis, I'm just going to install one of these on this like this, on the side that has 3 holes, and this one outside of the angle aluminum like this. On this one you will need like M5 bolts, 25mm or 20mm also will be fine. And on this one you will need like 10mm or 15mm M5 bolt. You can tighten the nuts and bolt later once everything is installed on the machine. Okay, so for the Y-axis I have all the pieces laid out here and even the bolt and nuts so I don't forget them. And for this build I will summarize all the type of bolt and nuts and how many you need them, so I can break down the cost and also what you need to buy. So first of all I have the 4 brackets here are the same, and those 2 pieces, just make sure that they kind of face each other in the kind of mirror way, so this piece face in. And now to install those pieces together, I just like put this piece. This is to mount the motor on the Y-axis, so I just put it on top of this one. And this one have the slot here, like for the M5 bolt, is faced this way. So now I just use some of the M6 bolt 45mm length, slide through the holes here. And then I pre-install the drop-in T-nut. I'm going to do the same for the other side. And here for the front of the machine you need some of the M6 25mm length. Okay, so now just install those bars. First of all, you just got to take this bracket and take this bolt M8 50mm length, slide through this hole, and this one on top, and the same here. Okay, so the bolts are a bit too long, so I guess I will have to use some washer here to space them out. So M8 for 45mm length will be perfect. Now I'm just going to install the rail on the bar here like this. So I'm just going to pre-install some of the M6 bolt here, 10mm length through the hole, and drop in T-nut. Okay, and before fixing them on here, I need to slide in the linear bearing block first. Now you can pre-install those two plates for the side of the x-axis. Just remember that this plate with the hole here face outward, and this is the back and this is the front that have only one plate. I just going to use some of the M6 25mm length. Now these two plates are installed. Next step, I just going to install the bar and the rails on the x-axis. With my experience from the plasma cutter build, I should install the rails on the bars first before I install them on the plate here. And just to make sure that they are aligned together, I just going to use the block here just I used to cut the bars. Okay, so now I have one set of the bars and rail ready. I'm just going to install them on the plate like this. Okay, so I'm just going to do the same for the other set. Okay, so now the next step, I'm just going to fix these two short bars here underneath here to fix the frame together. What I'm going to do is just I'm going to fix this side first, and then I just slide this back and forth so make sure that it moves smoothly, and I fix this side. Okay, so now just slide this all the way to the front and then tighten the bolt and slide it back all the way to the back here and tighten the bolts at the back. And that's it, I have the main frame put together. The next step, I'm just going to put together the Z-axis block. So remember, just I have the 4 holes here on the edge that I need to drill. So to do that, I'm just going to fix the rail on here first using these 2 holes. So I just have to use some of the M6 30mm length. And now I'm just going to tighten the bolt here. And then I'm just going to drill the hole with my 6mm drill bit. And now I'm just going to tighten the other bolt. Next step, before I install this block on the machine, I'm just going to install the nut housing on the back of this plate. Now I can install this block on the machine. On this side where's the big hole here, I just want to slide in 2 of the long M5 bolts through here and push the bolt into the slot here. Then I push this piece in here. Okay, so now I just want to bolt this piece down with some nuts and then slide this last screw through here. Now I just slide the last screw all the way through here, and then I can install this piece on this side like this, and then I can push this end of the last screw inside the bearing here, and then set the set screw on this side. Now I can tighten the set screw here. I just leave a little bit here so I can attach the coupler later. Now this block is installed on the machine. I just realized that I need to install a stopper here so the linear bearing block doesn't slide all the way out here and fall off the machine. Okay, so to do that I just made this piece of angled aluminum and I drilled the 2 holes here with the 4.5mm drill bit, and then I just want to clamp it on here and I just drill it through here with the same drill bit. And then I take this off and I drill it again with the 5mm drill bit. And then I just want to thread these 2 holes with a 5mm tab. That's why I can fix this on here using some of the M5 bolt. And that's it, I only need 1 stopper. Next step, I just got to install this last screw on this block. I just got to install these 2 pieces first. I just slide this M6 bolt through here and then I just tighten it with the thread hole here. Okay, now I just slide this piece up here like this. And then I just going to install this piece down here. Okay, now I can slide this last screw inside the bearing inside here. I just leave a little bit here, just enough to slide the coupler on, and I can adjust this distance later if needed. Okay, so next step I just going to install this gantry plate on here, and I just install loosely this bearing block on the back of this plate. And I also need to slide some of the M6 15mm length through here from the back to the front. Okay, so now just slide it on here. Just make sure this side is facing downward where the bolt is closer to the edge. Okay, so as you can see, the stopper here, it just stopped this block from sliding all the way down. So now I can tighten all the bolts here. Just make sure that it still is moving smoothly after you tighten the bolt. And now you can fix this block to the nut housing. Next step, I need to install these 2 stopper pieces here, like this. Along with this piece at the back here, this piece is to mount the motor bracket. You will need 4 of those 55mm length M6 bolts. Now you can tighten the nut at the back to pull the head of the bolt inside the socket here. Or I guess you can just pound it in with the hammer. And that also works. Okay, I just wanted to install this motor bracket on this, and I just realized that I put the hose in reverse. The hose here closer to the edge should be up here. Now I just installed the motor bracket on this, and this bracket is for Nema 23. I think this machine deserves something better compared to the 3018 CNC. And you will need some of the M4 bolts, about like 25-30mm length. Just slide them through the hole here. Okay, so now I just install the coupler on here. I just slide the motor in here, just to make sure that it goes deep enough so I can set the screw on it, and I think it did, so that's going to be perfect. So now I can tighten the bracket down. I have little problem here, just I cannot tighten the nuts here at the back. Here I don't have enough space, so I think just before I install this plate on this back of the Z-axis block, I should fix the bracket, fix the motor on the bracket, and then I can adjust the position of the coupler here with the less screw if it's like too low or too high, instead of adjusting the position of the motor and the bracket. For the spindle, I just going to use this router that I found on eBay for $33, and I'm sure that it is more powerful compared to the one that I have on the 3018 CNC. And the body of this is about 2.5 inch, 64mm. And to mount the spindle, I'm just going to make this plate, and I have this 2U bolt 2.5 inch pipe clamp. I bought this for like less than $1 per piece at the store, so I just going to slide it into the hole here. Put on the washer and pre-install the nuts. And now I just slide the spindle in here like this and tighten the nuts. Just make sure that you don't slide it too deep inside, so the flat part lay on this plate. Once the spindle is tightened, I'm just going to install it on here. Okay, so I think that I have a better way to install this. I'm just going to fix the bolt here with some nuts so they don't move. And that's it, I'm done with the Z-axis. It's really sturdy. Okay, so the next step, I just going to install the stepper motor on the X-axis right here. So first of all, I just going to fix the coupler on the shaft of the motor. Now just take some of the M5 bolt, probably 35mm length will be fine. So just slide through the holes here. Then now just slide it in here. Okay, so now the hardest part is done. The two less screw on the Y-axis is going to be very easy. Okay, so I'm just going to slide the less screw with the nut housing here, inside here, and then use some of the M6 bolt about 25 or 30mm length and fix it here. This side is to install the stepper motor, so I'm just going to install this piece on here, like this, using some of the M5 25mm length. Okay, so I think that I should slide those pieces on here first and then slide them back on the bolt to tighten them, because here it's really hard to adjust both sides to slide back here. Okay, so now I just want to tighten the set screw here, just to make sure that I leave about this much at the back here. It seems that the last screw is not long enough to stay inside the bearing here, so I just want to slide it back in here. Put some of the M6 nut here as spacer to space it up, so the last screw going to stay inside the bearing like this. So I think that I need about 2 or 3 M6 nuts here. That's it, I'm done with the mechanical part. Next step, I just going to install the control board, run the wire. That part I will show you very quickly how it looked like, and afterward I can show you what this machine can do. I'm done wiring the machine, and the thing to pay attention the most to is the wiring from the Z-axis here. You go all the way through the cable rack and go on this side, go down here, and all the wire on the Z-axis and A-axis will be tightened together and go all the way to the back and put together with the wire from the Y-axis, and everything will be connected to the control unit here. Here I have the wires run through the cable rack here. It's just to prevent it from tangling up with the axis when it's moving back and forth. Normally people use the drag chain, but for this small machine you don't really need to. Cable wrap will be fine. And let me just explain a bit the wiring at the back there. As you can see here, I use 3 different connectors for the X, Y and Z axis, so I cannot really mix up the wire. And here for the router, instead of cutting the wire here to connect it to the relay, I just use this plug and connect this plug to the relay instead of this wire, so every time I can just plug this in. This is not really in the original design. You can just connect all the wire directly to the control unit, but for me I do this because it will be easier when I move the machine, so I can move the control unit and the machine separately, and later on I can also use the control unit for other machine if I build something similar. So let me just explain a little bit the layout of the control unit. Here the control unit doesn't have anything special. I have this 2-stepper motor driver to control the Y-axis, this one for the X-axis and this one for the Z-axis. The 2-stepper motor on the Y-axis are parallel and they should rotate in the same orientation. So I just connect everything like the same. Wiring, everything is parallel to each other. So that is very simple. I have 2 DC step down. This one is 2 step down from 36 volt to 10 volt, so I can power the relay. And this one is to step down from 36 volt to 24 volts, so I can power the control board. And this relay is to open or close one of the wire for the router, either neutral or line, whatever you choose. And this control board, I bought it on AliExpress for $11, so it's really cheap and it's compatible with Match 3, so it's very convenient and very easy to control the machine. So let me just show you how all the axes move. As you can see that all the axes move really smoothly and I cannot really feel any type of loose movement, so this machine will be really good. And let me just test the spindle relay. It's kind of loud because it's a router and it's also a brass motor, but it's also like a lot more powerful compared to the 3018 CNC spindle, so it will cut a lot smoother. Next step, I just going to try to install quickly a wasteboard setup and then the machine will be ready to go. For the base of the wasteboard, I cut this board. The size is 580mm and 340mm, so I can slide it in here. And as you can see that the length is a bit longer than the machine, just it stick out here a bit. Let me show you why. As you can see here that the spindle like stick out a bit forward. It's like outside of the boundary of the machine here, just because of the auto plate and the rails here like add up together. The dimension are really thicker than I thought at the beginning, so it like stick out a bit forward here. So that's why I cut it a bit like longer compared to the length of the machine. Next step, I just want to fix this plate on this bar and this bar here using some drop-in T-nuts. So to do that, I made like some line here. One line just in the middle here and two line here. The spacing between the two line is 470. The reason is just the length here of the machine is 500mm minus the side of one bar, so 470mm. So now what I'm going to do is just I'm going to put this plate in here like this, and I just going to clamp it a bit like so. This part like stick a bit forward here, and I just going to mill 3 slots here. So when I fix the board, the head of the board is like underneath this surface. That way when I fix the wasteboard on top here of this plate, it will be flat. Now I just going to try to fix this plate on here using some C-clamp at the back, and then I'm going to reference the middle here at the cross, and then I just going to mill the 3 slots. Well, I made a mistake that I put the bit a bit too far inside, so it couldn't go always through. So it just kind of lost step on the Z-axis, so now I just have to restart. I just going to put the bit a bit lower. Okay, to be safe, I just going to use this long bit. I'm not really familiar with this router, so I made a few mistakes when I fixed the bit. It's not tight enough and it keeps falling off when I mill. So I'm just going to try to do it again. I'm just going to try to mill the slot right next to the one I already milled. Okay, so this time the bit were really tight, everything was cut correctly. It just it was really loud, so I had to put on my ear protection to reduce the noise. Now I just flip the board over and do the same thing with this line. I forgot to tell you, just I milled a lot faster compared to the 3018 CNC. This is 2mm step down, 1200mm per minute for feed rate, and 250mm per minute for plunge rate. But everything will cut very smoothly, so I'm pretty happy with the power of this machine. Next step, I'm just going to fix this plate on the machine using some of the bolts and dropping T-nuts. Once the base is fixed on the frame, I cut this board like 280 by 360mm for the actual waste board, and I make the cross here is the center of the board. And next step, I'm just going to try to slide it in here like this. And then I'm just going to move the bit all the way forward so I know just where I have to put the edge of the plate to. Okay, so I'm just going to put the edge like about right here at the center of the bit. And then I'm just going to make sure that the space on the two sides is kind of symmetrical. Then I'm just going to use some thermal glue to glue the edge down. Now I just center the bit to the cross here and just 0 X and Y here. Now I have the two boards fixed together. Next step, I can do the face mill to make sure that this surface is parallel to the movement of the spindle, but I will do it later. I'm just going to show you quickly how this machine going to mill aluminum. I'm just going to go really fast, 1mm step down and 1200mm per minute for feed rate for additive clearing, and 500mm per minute for 2D contour. So let's see how it goes. everything went really smoothly. All the cuts are clean. There's no kind of like rumbling or shakiness, so I'm really happy with the power of this machine, and I'm really excited to do a lot of things with this in the future. To summarize about this machine, just it's really easy to make with your 3018 CNC. All the bracket and plate can be milled with your 3018 CNC as I showed you. The machine is more powerful, a lot more sturdy, and it's also very heavy. This is still like portable if you are really strong, but it's almost broke my back moving it from my basement to my garage. If you are not really in good shape, just take 2 persons to move it. Of course, there are still a few things just need to be improved. First of all, just the working range in the Z-axis here. Right now it's kind of limited from the surface of the washboard to the edge of the Z-axis block. It's only about 30 millimeter. This because of the size of the X-axis side plate here, because it was limited by the working area of the 3018 CNC. So now with the new bigger machine, just you have the working area about 280 and 380. So I can mill this plate about 60 or 70 millimeter higher. So I can take advantage of the full working range of the Z-axis is about 100 millimeter. And I also might need to install the limit switch, especially on the Y-axis. Because on the Y-axis you have 2 stepper motor, so if one just hit something first, it might kind of like lose the step first. It might change the angle of the X and Y axis, so that is not good. Also that the spindle is quite loud, like it's really loud. So in the future I might need to change this, but with this power right now, just even if it's loud, you can cut everything really fast. So it's kind of like the trade-off. Also, as you can see how smooth it is cutting aluminum. So in the future, if I have some more money, I can buy some of the aluminum plate and mill all the bracket and plate with aluminum. So the machine will be a lot more sturdy and precise. In the end, I wish that I know how to build this machine from the beginning when I first bought my 3018 CNC, so I don't need to do all the upgrades step by step, and it still wasn't that great compared to this machine. It is really like different level. This machine can do a lot of things like better and faster. So I hope that you will consider this design for your 3018 CNC